The objective for this lesson is to divide using an open area model and a partial quotients model. The structure of the open area will help students to find equal groups. The students have previously used arrays to visualize a model of rows and columns to help understand multiplication. They have also used arrays to divide a one-digit divisor or show the opposite of their multiplication by dividing the product by one factor to find the missing factor or quotient in a division problem. The open area model helps students find partial products that they add together to find the complete product in a multiplication problem. For division, we will use the open area model to find partial quotients. We call it an open area model since we will divide to find out how to fill in the sections on this open area. Fourth graders should know that a quotient is the answer to a division problem, which explains how many parts or pieces will be in each group. Students should also know the terms divisor and dividend. A divisor is the number of groups our total will be shared by, and the dividend is the total amount that we will split or divide. Partial quotient is the method of dividing where multiples of the divisor are subtracted from the dividend, and then all partial quotients are added together to find the complete quotient. Let's use the open area model to solve 63 divided by 3. The dividend or total is 63, and we place it to the right of the rectangle. We want to divide 63 into 3 equal groups, so 3 is the divisor. We know that 3 times our quotient will be equal to 63, so 3 is the divisor and is also a factor of 63. We solve to find the other factor or quotient. Next, let's draw in 2 horizontal rows to create 3 rows or groups within the rectangle. Let's divide by considering if we can subtract out sets of 10 from 63. 3 tens is 30, so we will place 10 in each group. Next, subtract 30 from the dividend. 63 minus 30 equals 33. Can we subtract another set of 3 tens? Yes, we can. So, give out 10 more to each of the 3 groups and subtract out another 30 from what's left of the dividend. 33 subtract 30 equals 3. With 3 left over, we can't subtract any more sets of 10. So, I will draw a column or vertical line to separate the partial quotients of 10 from the ones. If I give 1 more to each of the 3 groups, I will use up the last 3 ones in the dividend. There's nothing left to divide, so now we add the partial quotients together from the array to find the complete total or quotient. There is nothing left to divide, so now we add the partial quotients together from the open area model to find the complete total or quotient. 10 plus 1 equal 21 for each of the 3 groups. And now we know 63 divided by 3 equals 21. When we add all the partial products together, we can see that 21 is the other factor. 3 times 21 gives a product of 63. We have checked our division on the open area model with multiplication. 3 times 10 equal 30, and another 30, and 3 times 1 equal 3. 30 plus 30 plus 3 equals 63. Let's try another division problem using the open area model and partial quotients. Maya ran 84 miles over 7 weeks to train for a race. If she ran the same distance every week, how many miles did she run each week? We will be dividing the total miles into 7 groups to represent the 7 weeks Maya ran. We will need to draw in 6 horizontal lines with the area model to make 7 equal groups. Let's begin by finding partial quotients of 10. A 10 for each group would take away 70 from the dividend. 84 minus 70 equals 14. Do we have enough to give each group 10 more? No. So we will draw in the vertical line to separate out the tens and go ahead and find the next group of partial quotients. We know that 7 sets of 2, or 7 times 2, equals 14. So, give each group 2 ones as part of their quotient. If we subtract 14 from 14,
in the quotient, we are left with 0 remaining to divide. Let's add together all the partial quotients to notice that each group gets 10 plus 1 more, or 12 as the total quotient.
If 7 is one factor of 84, then 12 is the other. We can check our work with the multiplication from the area model. 7 times 10 equals 70, and 7 times 2 equal 14. And 70 plus 14 equal 84.
If we multiply 7 and 10, we get the partial product of 70, and when multiplying 7 times 2, we get the partial product of 14. Add these partial products together to get the total product of 7 times 12, which is 84, which relates to the dividend from our division problem.
In this lesson, our objective was to divide using an open area model and the partial quotients model. We met this objective by dividing our dividends into chunks of tens and ones to form partial quotients, and by adding the sum of all the partial quotients.